Hello everyone, I'm Ankit and you're watching StudyIQ IAS English channel. In our today's video, we'll try to understand why the yesterday's launch of ISRO's heaviest satellite so significant for India's space sector. Okay, now the notes that I will be using in this particular session, in case if you want to download them, and you should because these are important for your exams, you should go to this particular Telegram channel called as ATS Live. On this channel, you'll find the notes. You can download it from there. And while you're at it, please do not forget to subscribe to the channel also. So let us start by understanding the context of our today's video. Now, yesterday's was ISRO's first launch in 3 months. And this was done on the ISRO's LVM-3 rocket, which is another name of GSLV Mark III rocket, right? So this was the launch done of a communication satellite on an LVM-3 launch vehicle, and this was the satellite called as CMS-03, which is a communication satellite. Now, what was notable about it, that it was first time that ISRO itself has launched a satellite which weighs over 4,000 kilograms, and this was placed in a distant geosynchronous transfer orbit, also abbreviated as GTO. So why is this development so significant? That is what we are trying to understand in our today's video. Now, first, let us talk about this satellite. This is a multi-band communication satellite, and as you can understand, communication satellite needs to be deployed on an orbit which is much higher in altitude as compared to other kinds of orbit. So to deploy a communication satellite, you need to place it in a geostationary transfer orbit, geosynchronous orbit, or a geosynchronous satellite orbit, right? Now, these multi-band satellite, particularly the one sent yesterday, weighed about 4,410 kilograms, and this was placed in an orbit which is at an altitude of 29,970 kilometers. So to place a satellite so high up in the air, that is outside even the air in the orbit, the ISRO needed a very powerful launch vehicle, and that is why this services was provided by LMV-3 launch vehicle of ISRO. Now, up till now, until before this launch, to deploy such a heavy satellite in the outer orbits like GTO or GEO orbits, ISRO utilized the services of private sector agencies, be it Arianespace of France or be it SpaceX of US, right? But this current development is a milestone. First of all, it shows you the growing capability of LVM-3 rocket, and the modified versions of these rockets will be used in our future space missions, be it the Gaganyaan mission where humans of Indian origin will be put in space, or be it the deployment of Bharatiya Antariksh Station or BAS in the lower Earth orbit. So for that kind of deployment, ISRO is again going to use the LVM-3 launch vehicle. Now, first of all, earlier, the launch that has been done by GSLV satellite, it is one of the most successful. Now, GSLV Mark III is a developed version of GSLV satellite. So it is one of the most successful of GSLV series satellite, as all of its flight has able to put satellites successfully. However, its precursor, the GSLV Mark II, wasn't that successful, as 4 out of 18 total launches that it made did not result into satellite being placed into the orbit. And the success stories of LVM-3 launch vehicle includes successful deployment of Chandrayaan-2, Chandrayaan-3 that were mission to moon, as well as placement of communication satellites like GSAT-19 or GSAT-29. So this shows you how successful the LVM-3 has been for the ISRO as far as deployment of heavier payloads into space is concerned. So this was the success series. Now let us discuss more about the capability of GSLV-3, right? Now, earlier scheme of things, or the earlier kind of nomenclature that ISRO used to follow for naming its launch vehicle dependent upon which kind of satellite it is going to place and in which kind of orbit. For example, the workhorse of ISRO, that is Polar Satellite Launch Vehicle PSLV, was originally meant to deploy satellites into polar or low Earth orbit. And these kind of satellites are basically meant for remote sensing, or these are meant for Earth observation. So these kind of satellites, that is Earth observation satellites or remote sensing satellites, needs to be deployed at a lower altitude. So for that purpose, specifically PSLV was used. As far as communication satellites are concerned, communication satellites are first of all heavier in nature, and they needs to be deployed at a higher altitude. So for these purposes, you required a more powerful launch vehicle, and for that purpose GSLV or geosynchronous launch vehicle was developed to launch satellites which were more heavier and into much distant geosynchronous orbits. So this was the nomenclature that ISRO used to follow before. Polar Satellite Launch Vehicle PSLV for deployment of lighter Earth observation or remote sensing satellites into low Earth orbits or in polar orbits. Whereas heavier satellites like communication satellites were deployed using GSLV rockets, which were more powerful as they were able to carry on more heavier payloads into higher altitudes, that is altitudes like GEO altitudes, right? So this was the nomenclature ISRO used to follow earlier for naming its launch vehicle. Now, during the time of COVID-19 pandemic, after the breakout of Russia-Ukraine war, ISRO discovered an opportunity, and this opportunity came towards ISRO in names of OneWeb Satellite Company. Now, OneWeb Satellite Company planned to launch 72 communication satellites into orbits. So for that, it required services of Russian rockets. But as Russia-Ukraine war was going on, Russia refused to provide launch vehicle services to OneWeb Satellite, as these satellites could have been deployed for benefit of Ukraine. So this company approached ISRO, but ISRO had a problem. Although this satellite, which the OneWeb company required ISRO to deploy, it was heavier in payload, but it needed to be deployed in low Earth orbit. So the name itself, that is GSLV, originally implied that this kind of a launch vehicle would be used to place satellites at geostationary orbit. But here came another problem. It required to deploy higher payload, and this payload needed to be deployed in lower orbits. So that is why, to allow for newer nomenclature to develop, ISRO changed the name of GSLV satellite to LVM-3, right? So that is why this rocket was able to carry heavier payload, that is more than 5,700 kilograms, but this satellite was placed at a much lower orbit of 450 orbit that falls into low Earth orbit category. So that is why the naming scheme of this satellite launch vehicle was changed. Now, GSLV Mark III, also known as LVM-3, is a three-stage rocket, and this rocket uses a combination of first stage using solid fuel, second stage using liquid fuel, as well as a third cryogenic fuel-based engine, and therefore it is quite capable in nature. Now, the capability of this LVM-3 can be demonstrated by the fact that it can carry payloads up to 8,000 kilograms to low Earth orbit, which is the orbit ranging from altitudes of 2,000 kilometers from Earth's surface. Whereas the higher orbits are concerned, this LVM-3 rocket can carry 4,000 payloads in geosynchronous orbit. Geosynchronous orbit, to be precise, is 35,786 kilometers. So this is the capability of LVM-3. This much payload it can take in low Earth orbit, and 4,000 kilogram it can take at a higher orbit of geosynchronous orbit. Now, India had many heavier satellites in the past, but to deploy these satellites successfully at higher altitudes, ISRO before this mission required the services of foreign space companies, right? So for example, to deploy GSAT 11 satellite, which was more than 5,800 kilograms, and GSAT 24 satellite, which was more than 4,100 kilogram, ISRO utilized the launch vehicle provided by Arianespace, which is a French company. And it also used the services of Elon Musk SpaceX, which is an American-based company, to deploy G20 satellite, which is more than 4,700 kilograms in weight. So it increased the dependency of ISRO, dependency of India on foreign companies. And to reduce this dependency, ISRO decided to modify LVM-3. So what kind of modification was done? To accommodate a heavier satellite like the one which we sent yesterday, which is more than 4,410 kilograms to be precise, ISRO lowered the orbit of this aircraft or this rocket system precisely. I told you it can carry up to 4,000 kilogram of payload up to the altitude of 35,786 kilometers. So when you require to deploy a payload which is heavier than 4,000 kilograms, you need to reduce this orbit a little bit. So that is why the payload that ISRO carried yesterday, that is 4,410 kilograms worth of payload, this needed to be deployed at a lower orbit of about 29,970 kilogram. But does it mean that every of the future need of ISRO is covered? The answer is no. So ISRO is working to increase the carrying capacity of this launch vehicle, that is LVM-3, so that it can be used for future space missions like the human space flight, which is the name of Gaganyaan mission, right? And it can also carry the components which is meant to install the Bharatiya space station or Bharatiya Antariksh station. So in that regard, let us understand what kind of changes can ISRO make to the LVM-3 so that it becomes accustomed to carry heavier payloads in the future. Now, one of the changes ISRO can make is to increase the thrust produced by the third stage of this vehicle, that is the third stage, also known as cryogenic upper stage of the rocket. Now, this cryogenic upper stage is very significant. First of all, it provides you nearly 50% of the velocity that you need to successfully deploy a satellite into geostationary orbit. And currently, these services are provided by a C-25 stage cryogenic engine, which carries about 28,000 kilogram, and using this fuel, it provides you the thrust of 20 tons. Now, when you have to increase the thrust, the natural answer is that you'll also have to increase the amount of fuel it can carry. So, the proposed new C-32 stage that the future LVM-3 would carry, it will be capable of carrying 32,000 worth of fuel, kilograms worth of fuel, and therefore it will be able to produce 2 tons extra of thrust, that is 22 tons of thrust. So this is the first modification ISRO can make, that is on the third stage, which is the third stage of cryogenic upper stage. Okay, so this is the first modification. The second modification ISRO can do is on the second stage of this LVM-3 launch vehicle. Now, in the second stage, it currently uses a liquid fuel propelled aircraft engine. So instead, ISRO is planning to use a semi-cryogenic engine, which would provide the additional thrust meant in the second stage itself. Now, the cryogenic engine, which is used in the third stage, it usually carries 2 liquefied gases at extremely low temperature. Therefore, the name cryogenic. And presently, India's cryogenic engine uses liquefied oxygen and hydrogen. Now, semi-cryogenic engine, if ISRO were to develop it, it would use a mixture of liquefied gas and a liquefied liquid propellant. So, ISRO plans to use a refined kerosene as a liquid propellant and a liquefied oxygen as a gaseous propellant, which would make the second stage a semi-cryogenic stage. Now, one of the benefits of using a semi-cryogenic engine is that it provides you much improved thrust at a fraction of cost. So, therefore, this would be much cheaper as compared to the cryogenic stage. So these are the 2 changes that ISRO plans to make. Now, with this new engine, the vehicle, that is the updated LVM-3 in the future, would likely to become more capable. Instead of carrying 8,000 kilograms worth of payload to low Earth orbit, now it will be able to carry 10,000 kilograms of payload. And therefore, the heaviest payload up till now that the LVM has carried was 5,800 kilograms. So this can be increased now. Now, the increased capability of kerosene would be enough so that in future, LVM-3 would be able to carry the first or the lightest module of the proposed Bharatiya Antariksh space station, that is India's own version of International Space Station. But does this mean that the updated version of LVM-3 is answer to all future requirements of ISRO? The answer is no. As to launch some payload which is of much higher or much heavier in capability, you required a more powerful rocket. And therefore, ISRO is working to develop a new vehicle which will be called as a lunar module launch vehicle, which will be able to carry as much as 80,000 kilogram to low Earth orbit. And this will be mainly designed to carry out missions of sending humans to low Earth orbit or even to moon. So this is the future requirement that ISRO wants to make. It wants to make a more powerful engine or more powerful rocket which will be able to carry 10 times more the present amount of the updated LVM-3. So LVM-3 might be the answer of future requirements, but is it the complete solution of future requirement? The answer is no. Okay. Now, there is a practice question, exactly the PYQ that has appeared in UPSC before on this particular topic. We'll solve that PYQ, but before that, I needed to announce something. Now, we have decided to increase the admission period for our October batches, because many students communicated because of many reasons, mostly because they weren't able to gather the money for fees. They requested us to extend these batch. So happy news for all. We have extended the time for the batch starting to 5th of November, right? So up till now, you have the option to take admissions in October batch. That is up till 5th of November. And if you use the code ATS Live, this would fetch you maximum discounts, not just on 2027, but also on 2028 courses. So please pay close attention. ATS Live is solution to all your problems. It helps you get 7,000 rupees discount, which is a massive amount of money. Now let us try to solve the practice question of 2018. Read this question: with reference to India's satellite launch vehicles, consider the following statements. I told you the nomenclature ISRO used to follow was that PSLV was the rocket meant for lighter satellites deployed at lower Earth orbits, right? So PSLV launches the satellite useful for Earth resources monitoring, yes, and GSLV are designed mainly to launch communication satellites, which are heavier and they needed to be deployed at much higher altitude. So first statement is right. Satellite launched by PSLV appear to remain permanently fixed in the same position as viewed from a particular location of Earth. Now you know why communication satellite need to be deployed at a higher altitude, because at higher altitude, that is geosynchronous orbit, GEO, there the satellite or any space object would appear static from the Earth's point of view. So this geosynchronous orbit basically means that the time period it takes for that satellite to revolve around the Earth is the same time period as compared to the time period Earth takes to rotate around its own axis. That is why it is called as geosynchronous orbit. So from Earth's perspective, if a communication satellite is deployed in front of your eyes, much higher in the altitude, it would appear to be in the same position throughout the day, that is 24/7. Now these satellites are launched using GSLV rocket because communication satellites are heavier and they need to be deployed at 35,786 kilometers away from the Earth. So that is why GSLV is used. So second statement is incorrect. Third, GSLV Mark III is a fourth stage launch vehicle where first and third stage is solid propelled and second and fourth stage is liquid fuel propelled. This is incorrect. I told you GSLV is a three-stage rocket. In the first stage, we use solid fuel followed by liquid fuel followed by cryogenic engine, whereas PSLV is a four-stage rocket. Whereas in the first stage, first and third stage, we use solid fuel, and the second and fourth stage, we use liquid fuel. So third statement ideally should have been for PSLV. And that is why third statement is incorrect. So first and second and third statement are incorrect. First one is right and we have to identify the correct statement. So option A is your right answer. Understood? So this is how we solve questions. And you can understand the utility of our today's discussion is so that if a similar question appears later on in the prelims, and they do, by the way, you will be able to solve this question. Now, once again, if you want to download the notes, and you should because these are important, you can go to this particular Telegram channel. So with this, I'll take your permission. Please have a very good night.